Hi, thank you for choosing this video to watch. Today I'm going to be messing around with this vibratone horn, and it's basically just one of those alarms you see up near the ceilings of public buildings. I know that in my youth in the US public school system we have fire alarm practice drills, and if you're here you've probably heard this sound that's probably made by one of these. It's basically just connected right into the power system of the building, and when it charges up it vibrates this metal membrane that just clatters and clatters and clatters until it's shut off. So I found this in the trash, and I'm curious about what it looks like inside and how it works. Maybe I can get it to work. So I will bring the camera closer and we'll take a closer look.
And here is the alarm. And back there, shining in the distance, you can see the metal plate with a ring right up in front of it and a nut holding them together. And behind, this would be inside the wall, you see that there's a magnet. Well, this is a core of metal. It's a U-shaped core. And you can see here, it's a coil of wire around one side of this core. And one end of that wire is connected to the positive lead of the power mains, and the other side is connected to the negative. So that when it becomes charged, it sends electricity through, and that little core becomes an electromagnet. Now there's some kind of relationship between this metal membrane and the magnetic core, and I'm not sure what it is. I'm not sure how they're connected, but I do know that when the core is charged, it responds. And somehow it sucks that metal membrane up, and then when it discharges, it flexes back down because there's that little spring over there in the corner. And this happens 60 times per second because it's a 60 hertz frequency that runs through the power mains. I believe what happened here is, you see this little spot? I believe that this was in a fire and that got melted and the wires were compromised, so there's a short. So the electricity can't run through and there can be no sound. The only documentation I could find were these installation instructions, but my guess is that that magnetic core just kind of rests on a little seat on top of that membrane, and the membrane responds to the magnetic field more than anything mechanical. But that is what we're going to find out. So let's open it up.
Right, so here we go. Oops. Let's take this off. So here we see how it's wrapped around. Anyway, when the electromagnetic field fluctuates, it vibrates this membrane here because that is attached to that. Was it attached? It was attached. I don't know what it was. It was just sitting there. If I can fix it, that would be super cool. So the way you test if, basically this is what should be one complete wire that goes around and around and back out. So to test if this is the problem, I can just use my continuity tester. Put these together. Okay, and then if this wire is continuous, I will hear a beep. It's not continuous. Okay, so somewhere along here, this wire has been cut, which means it might be out of luck. But wouldn't it be nice if I could take this stuff off and find where the wire was cut and repair it? That'd be nice. Or I could take this all the way off, remove all this wire, and rewrap it. Wouldn't that be cool? Here's the thing I know I have. Where is it? Up here. This is basically the same stuff that's inside. It's a tiny 30 gauge wire, and it's inside a very thin sheath. Polyurethane. It's enameled somehow. So that means when I wrap it around, it won't touch itself, right? And that's what we want. And that's probably what happened here, is that the enamel on this wire got melted, and then these wires are now touching. So it would be silly for me to try to find where this is detached and reattach it, because the enamel's probably, this has all probably been mushed together. All the wires on this area right here have been mushed together. So let's see what I can do about okay. I bet if I was a good guy, I would take steel wool and clean every one of these little tines. Wouldn't that be a good guy thing to do? So interestingly, let's see, these are not magnetic, right? But when this coil is wrapped around them and a charge is applied through this wire, they become a little magnet. Here, take this off and then cut these and wind it back up, and just guess how many windings it takes. I guess I could count, but if they are really melted together, they won't come off in one single strand. So just take this off first and go to the spring winder, which I bought because I was going to make a giant spring reverb driver, which is basically what this is, really. And didn't succeed in that. So, but I kept the spring winder because it's such a nifty little. You know what? I think I need some. Goop. Some sauce. unwrap all of this and rewind it. That'll be fun. No, I'm going to turn off the camera and unwind it like this for the next, I don't know how long, but that's what I'm going to have to do. Just see how tiny this is? See if I can get it to glint off the light. There we go. That's what I'm going to replace with this. Okay, so here we go. Okay, well, that's it. It's all cleaned up. I mean, it's all cleaned out of wire. And I'm gonna wash this down. This is probably glue. We're hoping. And then I'll take this and wind it back on. We'll see if I have enough. I don't know if I have enough. We'll see. Well, here's the coil winder. Pretty simple. I have my little coil winder kit and realized that I have a bunch of these little jigs that I created to fit various things that I wanted to wind on. But this is too narrow to fit in here. So I clumsily made this wooden piece that should fit right in here. Right? So that is what I'm going to put together now and hopefully make a coil. Okay, well, this is about half as much as there was. You can see where the line of the tape was before. So I don't know if this is going to be enough wire to create a circuit, or not a circuit, but create an effective electromagnetic field. I don't know. The only way to know is to attach this to the other electrode. See, I attached the first one at the bottom, and now I'm going to attach this one to here. And I don't know if you heard, but I did, as I was winding this, the wire did catch on this peg a couple times. Kind of, you could hear a little snap. And I hope that doesn't mean that the enamel got worn off. That would suck. So there's lots of things that could have gone wrong, but the only way to find out is to take this off and do a test and find out. Okay. So I noticed that the previous person who put that together before kind of made a loop to make it a little stronger. That will do, and we'll just see if that's enough. Hooray! It's not discontinuous.
Well, I soaked all those little thin sheets of metal in vinegar overnight, and they came out pretty clean. So all it's up to do is to reassemble this core,
If I remember correctly,
and fit it into its little cradle, and make sure that the assembly is successful. And then we can all celebrate as we listen to 2 or 3 minutes of this alarm making a whole bunch of noise.
well, these are just soldered on lightly and screwed in haphazardly because I just wanted to see if it would work. So let's just plug this in and see if it'll make a noise. And if it does, hooray, I fixed it. Woo! It did! It made a noise! Yes! The noise is there! In there! Ha! Okay, I'm going to pause here because what's happened is I've gotten so curious about these vibratone horns that I went ahead and bought one on eBay. Turns out there's lots of them out there, and people, I don't know, I guess they take them out of walls, or technicians sell extra ones, I don't know. So, have it, wired it up to a switch, and just going to turn it on for you to hear what one really sounds like. And then I have another plan. So, first sound. That was a loud sound, as we would have guessed. So now I'm going to hook it up to a dimmer switch. And a dimmer switch is, as you know, you've seen it in your homes, you turn it one way and it lowers the amount of light that comes out of a light bulb. So, try to listen to that as I play with the vibraphone horn.
And I'm going to turn down the volume here and just get real close to this, because it's so fascinating to watch that metal as it shifts. And you can see it by the shadows, how the shadows kind of change. See it there? I mean, obviously, we know it's making sound and sound moves things, but I'm just fascinated by this.
Okay, so now there's another thing that's like a dimmer switch, but we call it a Variac. Variac is a sort of a brand name. But, oh god, it's a heavy, big old, it's a big old dimmer switch, basically. I don't know if you can see inside, but there's a transformer in there with a bunch of windings inside. And when you turn this knob, there's a little brush that runs along the top of this coil of wire. And as you see in the top here, starts at 0, that's 0%, and it runs all the way to 100%. So as the brush is down here at the bottom, 0% of the energy is getting through. Up at the top, 100%. And what this does, contrast to the dimmer switch, this maintains the sine wave that's going through the electrical system. So there's 60 cycles per second. That means every time a magnetic pulse reaches its highest magnitude, and then the lowest, that's 1 cycle. So 60 times that happens in a second when you plug your lamp into the wall. So that maintains that cycle, but it just kind of squashes it down a little bit. And we'll hear what happens when that runs through the vibraphone horn. This is a heavy, darn object. So let's do that. There's a positive and a negative and a ground wire coming out of there, and I've just connected them. I haven't connected them yet, the power, but connected them to this power cord. Power cord goes in here. Doink. And then this gets plugged in to the socket. Zero %, 10, 20, 30. don't know if you noticed the difference between the dimmer switch and the variable auto transformer, also known as Variac. But I could hear that with the Variac, the ramp up was much smoother, and it seemed to be a little more musical. So that made me think, and I'm sure you were thinking at the same time, what if we could make music with it? So that's my next project. I don't know if I'll get to it during this video. But while I was doing that, I was also recording it with two microphones, and I've put it on a tape player. So I'm going to take you over to my tape player and see what it sounds like when it's slowed down a lot. So I'll show you what I mean. So this little device is homemade. It's a pulse width modulation motor controller. And basically what that means is when I turn this knob, it controls the motor of the tape deck. So I can slow it way down, and I can't actually, with this one, I can't actually speed it up. I didn't configure it that way. This is the simplest of the designs. But we will play this. 20, 30. Well, that was almost musical, but I think I can do better. Basically what I was doing with the vibratone horn was increasing and lowering the amplitude. And what I'd like to do is change that, make that change very quick, and change the frequency of that pitch. Basically making a melody. And I have an idea about how to do that. I've been doing a little research. I think I know how to do it. But the theory is, I'll show you on this modular synthesizer. Basically what I have here is an oscillator, which is what the vibratone horn really is. It's just rapid changes on up and down, back and forth, to make a change in the air that I can hear with my ears. That's what's happening here. I'm changing the frequency, higher frequency, lower frequency, and with this voltage controlled amplifier I can change the amplitude, lower, higher, right? So all a melody is a rapid change on and off to make a single note, and each one of those notes is a different pitch in succession, in a sequence. So you use a little sequencer. So I push this button, and in order, each one of these little stations will send out a different voltage, and the voltage, it corresponds to a pitch. So I can change a lot with the modular synthesizer. That's what is good about a modular synthesizer. Make all these little tiny changes. And as an electronics hobbyist, I think I can create a circuit that does this to the vibratone horn. I'll show you what I'm thinking of. So basically what I want to do is I want to take this vibrating metal membrane and attach a sequencer to it. In between there'd be the VCA, the voltage controlled amplifier. So on the modular, that's exactly what happens. But on this, my sequencer is direct current, very low voltage. This is alternating current, and it's high voltage. So what I need to do in between the VCA and this is create a circuit to modulate the frequency of the current and voltage coming through. So that does exist. It's called a variable frequency drive. And there's a fellow on YouTube and also on Patreon who created this schematic for a variable frequency drive. His name, the channel is called Mr. Carlson's Lab, and he offers these schematics for his patrons. So I thought it was worth becoming a patron because I wanted access to the stuff like this. He created this because, and I don't know if I could have even approximated the complexity of this. This is high class. Basically, I don't know if you can read schematics, but this part right here, it represents a transformer. So that's a transformer that I took out of a tape deck. And normally you would have a cord going into the wall socket, but what this schematic shows is that he puts a little, he steps it down to a DC current, and then he uses this little chip here, which is basically an oscillator, to introduce a different frequency to this transformer, and then that is transferred to whatever. He uses it for a pump. I'm using it for vibratone, I hope. And he doesn't need to change the frequency like over time. He just needs to be able to change it once. So he has a little trimmer here that he can adjust it and make it just perfect. What I would do is attach my my VCA and my sequencer to this oscillator, just with a little jack. So that is the plan. This is very complex. It's big, and he actually provides for us something that maybe I've shown you before. These are the plans for his circuit board, so I could just print that onto a copper-clad piece of fiberglass and attach all my components to it. Except that this section is SMD, which are teeny tiny little parts, and I'm just not confident. I mean, first of all, we're dealing with AC, and I'm not confident with that. These, I've never soldered an SMD part before. These are SMDs. These are too, compared to these big ones. So there's a lot of firsts for this. I don't know if this is going to be the project for me. I might just be satisfied with plugging this in every once in a while and vibrating my house. But if you see in the future that I've done this, then I hope you watch that video. Thank you.
Brain.